Hello. Today we're going to work with operations with scientific notation. Okay, so the first thing we're going to work with is adding and subtracting with scientific notation. And they can be added and subtracted either directly or by rewriting them in standard form. But because scientific notation is used for very, very large and very, very small numbers, if you knew how to do them in scientific notation, it could save you quite a bit of time and also reduce the possibility of error. The table below shows the population of the 3 largest countries in North America in 2011. Find the total population of these countries. So here we have the United States at 3 1/10 times 10 to the 8th. Then we have Canada, which is 3 3/800 times 10 to the 7th power. And then we have Mexico, 1 1/10 times 10 to the 8th power. So one way to do this is you can add and subtract as long as your powers of 10 are the same. And so what we can do is we can convert them all to the same power of 10. Now since I have a power of 8 and a power of 8 here, I'm going to change this power of 7 to a power of 8. And remember, when we're adding powers, the decimal moves left. So we're going to go left 1 place because 7 plus 1 is 8. And that's going to give me this. So now I'm going to write my United States had 3.1. Canada had 0.338. And Mexico had 1.1. And now we can just add these numbers together. And so I'm going to have the 3.1 and the 0.338 and add that to 1.1. And that's going to give us 4.538. Because now all of them are the same, this answer is just written as 4.538 times 10 to the 8th power. Okay, so that's one way. The other way is to convert them all to standard form and then add them. Okay, so remember, I guess I need this yet. We had 3.1 times 10 to the 8th power. We had, I'm going to go ahead and go back with the original on this one, 3.38 times 10 to the 7th power. And then we had 1.1 times 10 to the 8th power. Okay, and that'll give us more room to work. Okay, so what we're going to do is we're going to convert scientific notation to standard form. And so remember, when I'm making the powers, we move the decimal to the left. When we're undoing it, we move the decimal to the right. So we have 3, 1, 2, 3, 4, 5, 6, 7, 8 places. So we have 310 million. This one, we're going to move 7 places. So we have 1, 2, 3, 4, 5, 6, 7. So we have 33,800,000. And this one we're going to move 8. So we have 1, 2, 3, 4, 5, 6, 7, 8. And this one we have 110 million. So we're going to take those amounts and we're going to add them together. And when I add those, let's see. We get 453,800,000. And if we were to put that into scientific notation, then we would move that decimal 1, 2, 3, 4, 5, 6, 7, 8 times. So 10 to the 8th. The decimal goes here between the 4 and the 5. And if you notice, this answer and this answer are the same. Okay? But which one stands for an easier time of making a mathematical error? If you said the second method, you're correct. Because you could put too many zeros in, you could misalign your numbers. There's several different things that could happen. So the scientific notation, if you put them all in the same powers and just add the multipliers, then it's a lot easier to get the answer with less chance of a mistake. So let's try this one. Using the population table, how many more people live in Mexico than in Canada? And then write your number in scientific notation. So they want to know how many live in Mexico that's more than in Canada. So Mexico has the 1.1 times 10 to the 8th power, and Canada has the 338 thousandths to times 10 to the 8th power. So we're going to use those numbers again. So we have 1.1 times 10 to the 8th power, and we have 0.338 times 10 to the 8th power. Now, if I just subtract my multipliers, these powers of 10 are the same, so that's just going to stay the same. So we're going to take 1.1 minus 0.338. I get 0.762 times 10 to the 8th power. Now, they want us to write it in scientific notation. Is this in scientific notation? If you said no, you're correct. We want that decimal to be where there's one digit between 1 and 9 in front of that decimal. And right now, we have a 0 in front of that decimal. So we need to move that decimal one place to the right so that we have 7.62. And then our power of 10 is going to be, if you said 7, that's correct. Okay. Multiplying and dividing with scientific notation. They could be multiplied and divided directly by using those properties of exponents that we learned in previous lessons. So for example 2, it says, when the sun makes an orbit around the center of the Milky Way, it travels 2 and 25 thousandths times 10 to the 14th kilometers. The orbit takes 225 million years. At what rate does the sun travel? And they want to write the answer in scientific notation. So let's try to figure out what we're looking for. What we're looking for is the number of kilometers per year that the sun is going to be traveling around the Milky Way. And to do that, we need to divide. So we're going to take the distance divided by the time, and that's going to give us the rate per year. Okay? Next thing we're going to do is we're going to solve it. So if the distance is this and the time is this, we're going to place the 2 and 25 hundredths times 10 to the 14th kilometers on top. And then we're going to put the 225 million for years below that. So, and you'll notice they wrote it in standard notation. Now, it's easier to work with scientific notation. So what we're going to do is we're going to convert the 225 million into a scientific notation. And if I do that, I know that I want my decimal between the two 2's, and my powers of 10 are going to be 1, 2, 3, 4, 5, 6, 7, 8. That's going to be 8. Okay? So then we get this. Then we're going to find that quotient by dividing the decimals, and then we're going to use the laws of exponents to find out what our power of 10 is going to be. So if I take the 2 and 25 thousandths and we divide it by the 2 and 25 hundredths, we're going to get 9/10. So then we're going to have 9/10 times. Now to find the power of 10, I'm going to use that rule that if they have the same base, we just subtract those exponents. And so that's what they've done. Our base is 10, and our exponents are 14 and 8. So 14 minus 8 gives me 6. So it's going to be this. Now, is this in scientific notation? If you said no, you're correct, because the 9 is behind the decimal, and there's a 0 in front. And 0 does not fit between the numbers of 1 and 9. So I need to move that decimal one place to the right. And doing that means I'm going to take 1 away from my exponent. So then I'm going to get 9 times 10 to the 5th power. And that's going to tell me that it's 9 times 10 to the 5th power kilometers per year. That's my rate. Okay? So let's try number 2. Light travels at a speed of 1 and 86 hundredths times 10 to the 5th power miles per second. It takes light from the sun about 4 and 8/10 times 10 to the 3rd seconds to reach Saturn. Find the approximate distance from the sun to Saturn. And we're going to write our answer in scientific notation. All right, so this is going to help us set up what we're supposed to do. It says it takes this many miles per second, and there's this many seconds. So that's telling me that this is going to be a product. We're going to multiply, okay? So we're going to take 1 and 86 times 10 to the 5th power, and we're going to multiply it by 4 and 8/10 times 10 to the 3rd power. And we're going to multiply these. And one way of doing that is to separate the products. These are going to be multiplied times each other. And these are going to be multiplied by each other. Okay? So times 10 to the 5 plus 3 is 8. And over here, we have 1 and 86 hundredths times 4 and 8/10. And that gives us 8.928. So our answer to this product and how long it's going to take us is 8.928 times 10 to the 8th power. And is it in scientific notation? Yes, there is 1 digit to the left of the decimal, and it is between 1 and 9. Okay, take a look at number 3. Light travels at the speed of 1 and 17 hundredths times 10 to the 7th power miles per minute. Pluto's average distance is this many miles. On average, how long does it take the sunlight to reach Pluto? Write your answer in scientific notation. The first thing that I see is that this is in standard notation and this is in scientific notation. So what I'm going to do is I'm actually going to put this in scientific notation. Okay, so this becomes 3.67 times 10 to what power? If you said 9, you're correct. They want to know how long it takes to get for the sunlight to reach Pluto, and we're going to write that answer in scientific notation as well. So I have 1 and 17 hundredths times 10 to the 7th power and 3 and 67 hundredths times 10 to the 9th power. Am I going to multiply or am I going to divide? So in this case, we want to find the rates. We're actually going to divide. We're going to divide the distance between Pluto and the sun. We're going to divide that distance by the light speed. So we're going to take our 367 times 10 to the 9th power, and we're going to divide it by our 1 and 1700ths times 10 to the 7th power. If I take 3 and 6700ths and divide it by 1 and 1700ths, I get 3.13675, and it's just going to keep on going. And then my powers have a base of 10, so I'm just going to subtract my exponents, and 9 minus 7 is 2. I can round this to the nearest hundredth, and so that 6 is telling the 3 it's going to go up 1. So I'm going to have 3 and 1400ths times 10 to the 2nd power minutes. Okay. If you have any questions, please make sure you speak with your teacher.